So, you need to stop using CSV files, and to show you why, I've set up a bit of an experiment. So I've imported NumPy, Pandas, and PyArrow. We'll get back to what that does in a second. And I'm going to create a data frame with 5 million rows and 24 columns. The column headers are just the letters of the Greek alphabet. Just wanted to be a bit fancy. So if we make that now, we can see that the data is all values between 0 and 1. You know, this is representative of normalized data that you would feed to an AI. Maybe sensor data, who knows? All we know is that it's good mock data. Now to show you what I'm talking about, I'm going to do some read-write comparisons between a CSV file and something called a feather file. Now I'm going to set these cells going because this is going to take a little while to do, but I can talk about what these things are while it's going. Now before I want to talk about the feather file, I'm going to talk about the CSV file a bit, just so we have a bit of context as to why the feather file is better. So CSV files are comma-separated value files. Every row has a series of values separated by a comma, or in a TSV file, it's a tab. It's the same sort of idea. And each row gets formatted with all these values in between commas and then written out to the file in plain text, which is really good for a lot of things. CSV writers and readers are very, very easy to build. Plain text is easy to work with. However, it is quite expensive. As you can see here, it's taking quite a while to write this file, and that's because for each of the 5,000,001 rows, if we include the header row, it's having to format all these values between the column and then write them onto the disk, and that just takes time. And this is where the feather file comes in. So it's a binary file, and it's a representation of something called an Apache arrow table, which probably doesn't make an awful lot of sense to really anyone. But to explain what Apache arrow is very briefly, it's sort of it's an alternative to pandas. It's something that's available in any language pretty much. There's a lot of supported languages. Python just happens to be one of them. And I've used it for a bit, and I really don't like it. It's very obtuse, very difficult to work with, very difficult to actually get to do what you want it to do. However, the feather file format that it comes with is really, really nice, and essentially just saves an arrow table, which is sort of like a data frame, to this file just pretty much as a binary thing without any real encoding or anything, which is why it's so fast to write and also so fast to read, as you're going to see once the results start coming in quite soon, because I think that's about to do. And of course, these results do have overheads. I am recording, which means that these experiments will be slowed down a little bit. But, with the sort of speed difference that we're expecting, it's not going to make a huge difference, and you will kind of see, again, once all the results start coming in. And there the CSV file has been written, so we're now reading it again, using index column equals 0, otherwise it reads it slightly wrong. So again, with reading, it sort of has the same problem as writing does, where it has to read every single line, and it has to decode it, it has to split by comma, it has to load it all up. And that took about 24.3 seconds. And as you can see, the data is about the same. And if you scroll down, the feather file is already done. You can see, this is exactly what I was talking about. The feather file is actually a lot faster. I've actually taken a few takes at this video because it's kept going wrong. The feather file has actually taken a lot longer to write than it did before. The last take of this, it took 2.3 seconds. This time it's taken 4.2. Which perhaps says that, maybe it's not super consistent. But I mean, if we compare, for people on mobile that aren't going to be able to see the times, the CSV file took 2 minutes and 34 seconds to write. And the feather file took 4.2 seconds to write. In the previous take, it took 2.3 seconds to write, which I calculated as 68 times faster. And when you've got huge data, especially when you've got a lot of data sets that you need to analyze and read and write all over the place, especially if you're distributing data sets as well, this speed difference is huge. And on top of that, on top of being faster, it is also a lot more lightweight. So if you load the File Explorer and refresh our view, we can see that Windows Explorer has had a fit. And I'm going to have to show you some other way. Okay, there we go. I've managed to find another way to represent this. I was not expecting Windows Explorer to be weird. But as you can see, the data.csv file, if I can find my mouse, is 2.2 gigabytes. And the feather file is just 916 megs. So this is exactly the same data. But the CSV file is about twice the size, and it took, in this case, I think about 50 times the amount of time to read, or to write, sorry, which is nuts. And of course, when you're distributing this sort of thing, then you want to be able to know how much you can compress it. So obviously, CSV files can be compressed quite a lot if we just load the Z standard and we just compress data.csv with the default settings. We'll get a compression ratio of about 48%, and we'll be able to crush this 2.2 gigabyte file down to about 1 gigabyte. With the Feather file, however, because it's already binary, there's not really a huge amount it can be compressed. And so you end up with a compression ratio of, I think, about 94%. We'll demonstrate that once this is finished reading. This is with the Z standard, which, I find to be really good. The compression ratios are crazy. I once downloaded a 16 gig data set and it expanded out into 186 gigabytes. So this sound is actually really nice if you've never heard of it. But with the Feather file, as you can see, 94% compression ratio. There's not an awful lot it can do. It can still make it a bit smaller, and that's going to be big if you've got like hundreds of millions of rows. That's going to add up to quite a lot. But overall, Feather files are just kind of take them as they are. They are smaller, but they are just a lot faster to read and a lot faster to write as well. So one more thing I just wanted to show you is something to do with data types. It's quite a neat little thing. It's not as important potentially as being able to read and write very quickly, but it is a really nice thing that I found while experimenting around. So I have this separate CSV and separate Feather file. They were generated by a Python package called Analytics. I made a video about it before if you want to look at that. But the important thing is that these files have a month column, which is stored as a date time. Well, I can actually show you. So analytics.csv, as you can see, has date time information here. And when it's loaded, we can load them in and convert them into date time as you would. However, with Feather files, you don't have to do that because it actually remembers that it's stored as a date time. And I'm going to show you this real quick. So I just called this file video.py because I am amazingly inventive. And we can have a look at the dates, the data type. So we can see that month here is an object, which means that it is a string. So this is the one for the CSV. Our month is an object, so it is a string. However, if we go down here, we see that month is a datetime 64ns, which is what Pandas converts it to when you convert it to a datetime object. So Feather files actually preserve this information where CSV files don't. So this is particularly useful for time series data as well, because it remembers this information. So that was just a really cool thing that I wanted to show off as well. But that's pretty much everything I have for Feather files. It's a very basic rundown. I'm sure if you go down the rabbit hole, there's even more stuff going on. That's just mental. But it's really cool for reading and writing very quickly, for being very lightweight, and also preserving some information that CSV files do not. So it's just really cool all around. If you like this video, then consider liking to let me know. It helps out a lot. And maybe consider subscribing as well so you don't miss out on future videos like this. I'd like to thank my amazing patrons on screen now. £1 a month, you can be on that screen too. And I will see you next time for whatever I do, I guess. I don't know. So I'll see you for that.